This conference will now be recorded.
Hi everyone, we will now try to have an idea about the concept of regression. Regression is a very simple technique that is widely used in the field of data science. In order to understand this concept, let us look at this data, right? The values 1 to 8 are listed over here and the values 2 to 16 are listed over here. Do you find any relationship between this first set of values and the second set of values? Yes. You take any value here, multiplied by 2, you get the corresponding value here. You take this value, multiplied by 2, you get the corresponding value here. Suppose you write X here, and instead of writing salary, you write Y here. And then all these values become the values of X. All these values become the values of Y. Is idea clear? And then shall I say like this, you take any value of X, you multiply it by 2, you get the corresponding value of Y. So shall I say the relationship between X and Y like this? Y is equal to 2X. Y is equal to 2X. That is what I am writing here. That is what I am writing here. Y is equal to 2X. You take any value of X, you multiply it by 2, you get the corresponding value of Y. Now, this is known as, this is known as the regression equation or prediction equation. Why do you call it as a prediction equation? Suppose someone comes and asks me, I have 9 years of experience, how much salary can I expect? And then I can say, I will substitute 9 for X, and then I get 2 times 9 is equal to 18, and then I will tell him you will get 18 lakhs per annum as your salary. Suppose another person comes and tells me, I possess 10 years of experience, how much salary I can expect? And then I substitute 10 for X, and then I get 2 times 10 is equal to 20. So we understand that this equation helps us to predict the values. That is why it is known as, that is why it is known as prediction equation. In data science, it is also known as regression equation. This is actually a general form of this. Suppose you put C is equal to 0, and then this term will go off. Put M is equal to 2, and then you will get this one. So this is a general form of this one. This is actually the equation of a straight line. That is why it is also called as a linear relationship. Okay, so what do I want to say? The regression equation or prediction equation is nothing but the functional relationship between two variables X and Y. This is a variable X, this is a variable Y. Why do we call them as variables? The value varies. The value varies. Now, on the other hand, density of water never varies. Density of water was 1 yesterday. Density of water is 1 today. Density of water will be 1 tomorrow. So density is an example for constant, but years of experience differs from year to year. This year I possess 8 years of experience. Next year I will possess 9 years of experience. This year my salary is 16 lakhs per year. Next year my salary will be 18 lakhs per year. Anything that varies is a variable. So regression equation or prediction equation is nothing but the functional relationship between two variables X and Y. Here X is known as the independent variable and Y is known as the dependent variable. Why do they call Y as the dependent variable? See, when the years of experience changes, salary also changes. When 8 becomes 9, 16 becomes 18. When 9 becomes 10, 18 becomes 20. That is why I say this one depends on this. So this one is called the dependent variable and the other one is called the independent variable. Please remember, I will not repeat in the subsequent videos. Whenever I say I will always represent the independent variable as X, I will always represent the dependent variable as Y. Nowadays, the dependent variable is also known as the target variable. Independent variable is also known as the predictor variable. All right. When the data are really so simple, we can easily guess the regression relationship, right? Now, even if you are not able to guess the regression relationship, even if you are not able to guess the regression relationship, you can always get the help of a statistical procedure known as least square method to find out the regression equation. What do I want to say? If the data is really so simple, you can guess the regression equation. Now, what is the alternative? If you are not able to guess, you can use the statistical procedure. You see, there are two normal equations, right? You form a table. I have just reproduced the values from the previous slide and then say x, y, x times x, x times y. I find all the totals. Only these totals are used here. See, 408 and 204. And then when I solve this, when I solve these two simultaneous equations, I get c is equal to 0, m is equal to 2. Suppose I substitute c equal to 0 here and m is equal to 2 here. What will happen? This will go off and I will get y is equal to 2x. What do I want to say? Another way of finding regression equation is to use simple statistical procedure. Is there a third method? Yes, the third method is known as graphical method. Now suppose I take all this, I represent all these values of x on x-axis, I represent all these values of y on y-axis, and then you say when x is 1, y is 2. When x is 1, y is 2. Now this is represented by, see, according, say, from 1 you draw one perpendicular, from 2 you draw one parallel, both the lines will meet at this point. And then say when x is 2, y is 4. Take x is equal to 2 here, y equal to 4 here. You draw one perpendicular, draw one, right, another parallel line, parallel to x-axis, another, say, a horizontal line. This vertical line and horizontal line will meet at this point, and similarly you get all other points. You join all these points. You know, you would have studied in the school that the equation of this straight line is nothing but y is equal to 2x. So there are various ways of finding the regression equation. You sometimes, if the data is really so simple, you can guess it, or you can use a statistical procedure, or you can use a graphical procedure. But if the data is really very difficult, now we have considered this data, right? 1, 2, 3, 4, 8, or 2, 4, 6, 8, 16. The name of the data set is salary data 1. If the values are really complex, 1.1, 1.3 fractions, with these values involve fractions, and these values contain as many as 5 digits. Now guessing the relationship is not possible. Here we could guess y is equal to 2x, but here guessing is not possible. Here in the case of this data, we could use a simple statistical procedure. Now here, simple statistical procedure itself is difficult to use, because if you have 500 values, finding the squares, right, and then the cross products, adding all the 500 cross products is going to consume a lot of time. And then even the graphical method is not going to be very helpful, because plotting all these fractional values is going to be difficult. In such situations, we have to use programs like this. Now we will see the explanation for this program in the next video. Thank you.